Hello guys, welcome to another day for Networking Labs. My name is Mbebo Johnson Vola, your lecturer in this Networking Lab series. So in our previous lecture, we saw routing, especially static routing, and we saw how we could configure static routing. And in the concept of static routing, we saw that the challenge with it is the fact that it's very difficult or tedious to configure when you have to deal with sophisticated or large network. So that is where dynamic routing comes into play. And in dynamic routing, we say we are going to look at a RIP, OSPF, ERGP, and a border gateway protocol. But today, our main focus is on RIP. Our main focus today is on RIP. So we are going to see how RIP can help the situation or the stressful situation that we have to go through in static routing. So without wasting much time, let's get into Packet Tracer and see how this can be configured. So here we are in Packet Tracer with the same topology that we use to demonstrate static routing, and all its settings is still in place as we saw in the previous lecture while configuring static routing. So what we are going to do here is that we are simply going to go into these various routers and remove all the static routes that we have configured and see how RIP routing can help to save us time and the stress of configuring static routing. So I didn't want to design a new topology in order to save us time. So we will use this very topology to see how RIP routing or RIP protocol works. So if we come here and we look at the, let's say we look at the routing of this particular router, say show IP route, you'll see that this is the static IP address that we configured in this particular router. So this router has one static route. So what we are going to do is we are simply going to remove this static route. We go into the global configuration mode. That's where we make all the changes, and we paste. So let's say we negate this command. This is how we remove any setting that we have in a router or in a switch, by negating the command. So we say no IP route. Okay. We copied with so many invalid information that we did not need. So we don't need the var, we don't need the slash. So okay, I think it's okay like this. So why is it still refusing? Oh, okay. We have to define it all plus the subnet mask. So we come here, you say 255.255.255.0. okay, this is the information we entered in order to configure this static route. So what we have to simply do is to go and negate this command, and by so doing we remove this static route. Okay, so if we now say do show IP route, we see that there's no more routing in this router. It's just these directly connected interfaces. Okay, so we do the same thing with this. Come here, we look at where we set up the route. So this is the route that we set. This is it. So we copy, by so doing we can first of all check the routes that are here. Show IP route. So we see that there are two static routes. We are going to negate and remove all of them. Say no. The 30. What was the other one? Okay, this is the other route. So now let's see, do show IP route. So we see that there's no more routing here. We come here, do the same thing. So if you want to come to this in the beginning of your command, you just type Ctrl A and it would get you there. I think that's all. We can do show IP route. Okay. So presently there's no routing in this setup. If you try to ping this particular IP address, you will definitely see that the reply will be destination unreachable. So let's try to ping 192.168.40.2. So it says destination host unreachable, meaning that there is no routing protocol present in this network. Okay, so we are going to go ahead now and see how the magics work. So router RIP, what you have to know is that router RIP has two versions. You have version 1 and version 2, but the version 1 is out of date. We don't even use it. Normally, when you're taking Cisco CNA exam, you see that router RIP is not in the syllabus. This is because router RIP has some small downfall, or Cisco consider it to be not as much secured as the other routing protocol, but the protocol is still being in use today in some small networks, but many people prefer to use OSPF than RIP. But nevertheless, we are going to look at RIP because people are still using it today. It just depends on the nature of your network and, you know, the purpose of your network. So let's come here and see how the magic is being done. In order to configure RIP, the command is just router RIP. You put router RIP, and then you put the version. So it's version 2 that we are using. And then the next thing is to put the network that you want to advertise. So we are here, which means that what we have two networks that we want to advertise. We have the .10 network and the .20 network. So we come here, we say network 192.168.10.0 and we enter. Then we go now to the next network 192.168.20.0. Okay, by this we have already configured router RIP on this particular router. Okay, so we come now here, we do the same thing. So in this router knows two different networks. It knows the .20 network and it knows the .30 network. So we come here, we say router RIP version 2 network 192.168.20.0 network 192.168.30.0. we come here also, we do the same thing. Say router RIP version 2 network 192.168.30. What's that? Network 192.168.30.0 of network 192.168.40.0. Okay, so by this we have successfully configured router RIP on all this router. So now let's come and check the routing table of this router right now. Show boom. You see that it has now learned of this new route. See, so it now knows about the .40 network, and it also knows about the .30 network. Something that we previously saw how we did for it to know about these two networks. But now, by using router RIP, you see that it knows about the .30 and the .40 network. If you see here, you see arrow, and you come and look at this, what arrow stands for, it stands for RIP. So it has now learned about this other network and how to get to this network via this IP address and these interfaces. Okay, we come also to this one. We exit. We say do show IP route. Boom. You see, it now knows about .40 network, and it also knows about .10 network, which is this network. Okay, we come here to say show IP route. You see, so this router knows about the .20 network and the .10 network. So guys, you see how pretty simple it is when you use a routing protocol. So let's try to ping here and see something. Let's try to ping this. Say ping 192.168.40.2, and you see that it's successfully receiving a reply. So what is good about this protocol is that anywhere you stand in the network, you can communicate with any device in this network as long as the router there is running RIP. So if you bring another router here and connect to this router and configure RIP on it, it will learn about all the devices in this network. So we can say that RIP is like some sort of a gossip protocol. So it tells its neighbor what it knows about the network that is connected to. So let's say this router here knows about the 10 dot network and the 20 dot network. So it tells this other router that I know this network and I also know this network. And this router does the same thing by telling this other router that I know this network and I also know this network. So that is how they advertise to each other what they know. So let's say it's a form of a gossip protocol. So by so doing, the router learns about all the devices that are in the network, making it pretty simple and easier, rather than for you to go into the routers and configure static route in every direction. So you see how pretty simple it is. But the problem is that a router RIP has its own limitation. That is why it is not mostly recommended to be used. But we are not going to look much into that, because our main objective and purpose in this lecture is to see how we can implement the configuration of all this concept. But we are going to mention it. I believe those of you that have been taking CCNA exams or that are doing networking, if you have studied router RIP, you will know about auto summarization, which is one of the limitation factor of RIP. Because let's say we have very large network, and this network, let's say we have about let's say 5 routers before you get to this network. So once this network, let's say at this network you have a total different network that it has to go to, let's say a 10 dot something network. So this router here, at this point here, after gathering information about 5 or 6 different routers, it might summarize some of the information, and by so doing it will give a misleading information to this other router, because it wants to summarize and shorten the routing table of all the network that it knows here. So that is one of the limitation of RIP routing. Like I said, we are not going to go too much into theory. And we also have the problem of infinite loop. Like maybe let's say this device is let's say PC is here, and there is another PC somewhere here, and there's another PC somewhere here, and some way or something happened and the connection got broken. So it will update its table in such a way that there will be an infinite loop of continual updates. So, and by so doing, this will cause also a very challenging factor in the network. Then we also have the issue of distance. We also have the issue of distance vector. Remember, we also have the issue of distance vector. Remember, we said that the routing protocol have 2 different states. We have the distance vector state and the link state. I think I have a diagram of it here. Voila. So routing protocols have what is known as distance vector state, and you also have what is known as link state. So in the distance vector state, the most factor that is taken into consideration is the shortest path to get to the destination. So let's say we have configured RIP on this network. So you see here that from here to here we have 20 kilobytes as speed, and then we have here 100 megabytes, 100 megabyte, and 100 megabyte. This shows that if you want to send a packet from here to here, the best path for it to take is this path, because it has the highest speed. You have 100 megabit speed and 100 megabit speed and 100 megabit speed. So since RIP is a distance vector state protocol, it will instead choose to send the packet through this direction, which is having a speed of 20 kilobytes instead of using this 100 megabit path. Meanwhile, if it chooses to send the information or the packet through this direction, it will be much easier and much faster than sending it through this direction. So for it to be looking at the distance and not the speed of the network causes a problem of delay. So this is one limitation factor of router RIP, distance vector state. Whereas OSPF, when it look at its routing table, it will look at the distance and look at the one with the best and the fastest connection. OSPF will not choose this shortest path because it knows that the speed here is very much lower. It will prefer to choose the direction with the highest speed and send the packet through it. So this is the difference between RIP and OSPF. So guys, that's it about router RIP. It's a very simple protocol to configure, very easy, but it also has its limitation. So what we are going to look next, we are going to look at OSPF, its own advantages and how it is being configured. Okay guys, thank you for watching. Please don't forget to like, share and comment. See you in our next lecture.